Hello everyone, my name is Connor Smiley, and in this video I'll be showing off my robot path planning Android application. This path planner could be generalized to any field, but I was inspired to write this because of my work in the robotics industry, so let's view it in that context. To start off, we want to define a boundary area in which our robot must stay inside when performing a navigation. Furthermore, we can define obstacles within the boundary, which are areas the robot should avoid in order to navigate safely. Once we're happy with the geometry, we can add a list of waypoints, which are destinations the robot should seek to in order to complete its navigation goal. Once we're happy with all our information, we can save our path. However, if we have yet to create a path file, our application will notify us and tell us how to do so. So all we gotta do is click the create button and give our path a name. Let's call it test. So now you can see we have the file test.path and we can successfully save our data. If we want to view the path we just created, we press the load button followed by the corresponding path name, and we can see what we've just done. Here we can perform edits as well, so if we want to edit, let's say, our waypoints, we can start by removing some based on wherever we click. So when you press the remove button, it removes the point and then highlights the previous point, making it the new current selection. We can keep doing this until we run out of previous points, in which case the editor will snap around to the last point, and finally if there's no more points to remove, the state defaults to add, so we can have some new points. The add and remove feature works for all 3 point types, so we can remove boundary points. Also, the way to revert from remove to add is to long click the corresponding button, so now we can add that point back in there, and we can also do this for obstacles. So we can remove a couple points, long click to add, and finalize our obstacles once we're happy. Looking great, so we can save that. And as you may have noticed, we have support for multiple paths. So I was goofing around and made 2 paths earlier before recording this, so let's take a look at them. We've got smile, and we've got frown, and of course we've got test, the path we've just created. So if we want to remove some of our silly paths, we can go ahead and use the delete feature to click the corresponding path name. So now frown and smile no longer exist, and we are left with test. And now for the fun part. So, most of the input events in this application go through Google Maps, most notably the map click event and the marker click event. Whenever there's a map click event, that generally means we're adding a point to a map, and when there's a marker click event, that means we're selecting a marker for removal, which we'll follow up on based on a corresponding button click event. So, I have a class called editor, which basically encapsulates both these map click and marker click operations. Let's take a closer look at this. So the editor is composed of 3 members called way, boundary, and obstacles, each referring to the type-specific points. Now, when we look at one of these classes, they all implement the same common iPoint interface, which define the 4 operations, once again, map click and marker click for add and remove, and button click to perform the selected operation in the case of removing, and long click to reset the state. So now that we've defined these 4 common operations, let's take a look at how they work. So simply put right here, if the state is add, we're going to add a marker, and if the state is if we've clicked a marker, we change this state to remove, update our selected marker based off of what we've clicked, and if we actually click the corresponding button, we're gonna remove the marker depending on the state, and also revert it if there's no more markers to remove. As I said earlier, long click will revert the state to add, and we've also got some other convenience methods for file loading. So when we're loading, we're basically just passed an array of binary data because we use serialization for our persistent storage. More on that later, but we're just going to clear the existing selection and add all our points to the map. Clear, pretty straightforward. We're just going to reset the markers container and the lines container. Points fetches our data as an array list. We keep our state setter internal because we want to encapsulate as much information as possible. the three states are independent of each other, so that's always nice. And finally, here are our members. Markers is a very cool class. When I first wrote this, I made three distinct types of markers, but then that started to cause problems when interacting with the Google Maps functions because I was only given a marker, so by deriving from a Google Maps marker, that would just create a big headache for me. So what I did instead was pass in a type as a tag parameter to a marker. I'll show you more about what this means. So whenever we add a Google Maps marker to the mix, marker, it might be a bit confusing because here we've got the Google Maps markers, whereas my class name is markers. But anyways, when we add a marker, we set a tag based off of the corresponding type enum, which can be one of three things, simply way, boundary, or obstacle. So that way we can determine type later when we've clicked a marker. And also we have some logic to set the selected marker accordingly based on how many markers exist within the map and which marker the user has clicked. Similarly with removing, we want to handle the selected marker accordingly and remove it from the container. Clear, set selected, relatively straightforward. Again, we have a points getter to forward to the higher level classes right here. And again, some more private helper methods. So now that I've explained my markers class, let's continue on. I'd just like to add that the markers class was an extremely convenient code reuse tool, and it allowed me to make my code very legible. For example, my top level classes like boundary and whatnot, everything that implements the point interface, read almost like English, where, you know, we've got 2 lines here for add, 2 lines for remove, and the underlying markers class actually handles the nitty-gritty details. Even if we look at something like obstacle, which is the most complicated of the 3 buttons, because in addition to markers, it actually has a collection of polygons in the form of a map. In order to have reasonable performance, rather than brute force searching for a marker when we click it, we have a map of unique IDs per polygon. So this time when we call marker click, we're gonna search for the polygon based off of the ID stored in our map and then update that set of markers accordingly. Furthermore, we've got a helper class defined within obstacles called polygon. Again, not to be confused with Google Maps polygon, this extends my markers class. So in addition to calling the markers add and remove functions, we're going to interact with a Google Maps polygon in a similar manner based off of how many points are within the polygon and whatnot, as well as some matching options for rendering. So now you've seen the 3 most fundamental components, the ways, boundaries, and obstacles that are very similar yet distinct enough from each other. The only other notable part of this application would be my serializer. So unfortunately, the Google Maps lat long data structure does not implement the serializable interface in its finals, so we can't do much about it. It uses parsellables, but I don't think those work for persistent storage, so I had to write some boilerplate code so I could implement the serializable interface. But now that we have that, let's look at how we're actually writing our binary data. So we've got 2 convenient static methods that accept generics that extend serializable, called serialize and deserialize, where all we're doing is we're reading and writing our binary data to a file stream all in one go. So this will truncate the file, but that's okay since there's no need for any sort of random binary access within our files because they'll be so small. And the reason I chose serialization over text was because this is kind of just like an automatic file writer. Instead of choosing some protocol with text files, we just let the Java serializer handle what goes where, as long as I can come up with an intuitive memory layout to write to the files and keep that persistent. Also, still going, I used Event Bus to create a generic event system where we pass in some random data and we just store it. It's nice and immutable. The only place we used this class was in the path name view recycler view. And I really have a bone to pick with the way Android implemented recycler views because it's very hard to forward click events to an outer class unless I were to take this whole class and slap it in my max activity, which would have been okay again due to the small nature of this application. But if it were to grow larger, there would be too much redundant code in one place. So I decided to use event bus to forward this click event and then listen for it right here in the, what's it called, item click event. So this way we have the surrounding context that lets us glue all of our components together whenever the user clicks a map button. So that's about it. This has been a pretty neat application that's multifaceted, kind of a working of example of what I'd consider clean code with a valid use case. So thanks for checking it out.